Good morning, everyone. So, welcome to my YouTube channel, Maths Akram. So, today we are going to see fourth lecture on power series. Today we will study Taylor series and Maclaurin series. Okay. So, today we will study Taylor series and Maclaurin series. So, definition: let f be a function with derivatives of f derivatives of all orders orders throughout throughout some open interval an open interval containing A containing A. A is a point. Okay. Then the Taylor series generated by F generated by F at x is equal to A is summation A goes to 0 to infinity. Kth derivative of F at A upon factorial K into x minus A to the power K. It means what is this series? How to expand it? F A plus F dash A x minus A plus F double dash A upon factorial to x minus A square plus F and derivative of A upon factorial n x minus A to the power n, and this is going and so on. Okay. So this is the definition of Taylor series. This series is called Taylor series. And the next, what is Maclaurin series? The Maclaurin of F is the Taylor series generated by f at x is equal to 0. Okay, it means you can say it means the series Maclaurin series is this. K goes to 0 to infinity. Take derivative of f to 0 factorial to the power k has to 0 f dash 0 x plus f double dash. So this is the formula of Maclaurin series generated by f. No, not the mark. The Maclaurin series generated by f is often just called the Taylor series. Of in some book or somewhere you will find that Maclaurin series generated by it is often called Taylor series. In some books it is written. No problem. Question example number 1. Find the Taylor series generated by f is equal to 1 upon x at a is equal to 2. Whether, if any whether does this series converge to 1 upon x what is f dash is what is f dash x what is different as and so on. What you will get up to the power and the derivative of x is minus 1 to the power n factorial x to the power minus n plus 1 so that f2 is 1 by 2 f dash 2 is minus 1 upon 2 is square. F double dash 2 upon factorial 2 is equal to 2 to the 1 minus 3 f on 2 upon factorial and is the Taylor series is f2 plus f dash 2x minus 2 f double dash 2 upon factorial 2 f minus 2 square. This is equal to 1 by 10 x minus 2 upon 2 square x minus 2. Now, this is a geometric series. A geometric series with first term 1 by 2 and common ratio r is equal to x minus 2 upon 2. It converges absolutely for things and its sum is okay. So this is the example. In this example, the Taylor series generated by fx is equal to 1 upon x at a is equal to 2 converges to 1 upon x. So, it means in this term. Now example 2. check that f and derivative of f at 0 is 0 for all. This means that the Taylor series generated by f and x is equal to 0 is f 0 plus f times 0 x f interval times 0 this part is 0. This is finally 0. This series converges for every x. Every x. Its sum is 0. But converges to fx only at x is equal to 0. Because if x not equal to 0, then fx is equal to e to the power minus 1 square, that is non-zero. But series sum is 0. Therefore, the series converges to fx only at x is equal to 0. So in this case, the Taylor series of fx converges to function f only at x equal to 0, except other points it is not converging. So in this lecture, we have studied what is Taylor series, what is Maclaurin series, and we have found out those two examples. First, in a first example, the series converges generated by some function converges to that function. In second example, the series converges to does not converge to function. Uh, Taylor series of function does not converging to function in the interval where the Taylor series is existing. Okay. There are some points, many points. Only one point it is converging. So we conclude that sometime Taylor series generated by some function will converge to that function, or sometime it will not converge. Okay. So in uh, consequent lecture, we'll find condition under which it converges to the generating function, or it does not converge. Okay. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.